Hey Rex, cleverness is serviceable for everything, sufficient for nothing. Serviceable for everything, sufficient for nothing. That sounds kind of harsh. I feel like cleverness gets you pretty freaking far in life. I don't know. All right, I'll show you guys what I'm working on. Just let me take another bite of my yogurt. Actually, let me pull up the genesis of this. The Terminator Genesis. Is that a movie? That's a movie, right? I think I've seen that movie. Terminator Genesis. Oh, it's spelled with a Y for some reason. I don't remember. I don't think it was very good. Apparently, I've looked at the Wikipedia page before. Dude, I don't know why I get distracted so easily. The last time I streamed, Femlux and I did an E&M midterm, and there was this really cool question about a charged particle moving through a uniform magnetic field. That uniform field will split down the middle with two different values for positive and negative x. And if you give the particle some initial velocity in the x direction, you have a really cool path that it follows. Let me take another bite. And so I guess while I'm chewing, I'll flip back over to the code and show the animation that I have so far. I want to refine it though. Zach did the first midterm. This is like a second midterm on like later material, but they are both from Dr. Cook. So yeah, it has this like kind of spiral pattern, and like I said, I still need to. This animation is not perfect yet. I don't know why this rectangle got so stupid. I also like I want this dot to like leave a trail as it travels, so you can see what its path has been. That'll make the rectangle not stupid. Okay, and so kind of how I did this is I tried to code it all on my own, and then I went and asked AI how to do it. and AI did it much better than I did, to no surprise. This is what the AI spit out that I was going to kind of like go through. Yeah, 6-7. And so the main thing that AI did better than me is it uses this funk animation thing that I haven't had any experience with, but it seems like the right tool for the job compared to the artist animation thing that I did here. And so I'm probably just going to comment all of that out. Ooh, congrats on the first. Slim, thank you again for the raid. Do you want to be in my band? It's called Pancakes at the Disco. We'll do pancake parodies of songs. Here's some two live crew covers. I would love to be in your band, Slim. Pancakes at the Disco. That's an amazing idea for a band. I think my favorite like I guess like joke band or gimmick band. I don't know what you want to call them. Um, it's a metal band where they all dress up as Ned Flanders from The Simpsons. What's the one that I'm thinking of? Wow, they have a lot of songs that they've done. Okay, yeah, oop, this will get buy me some time to eat more yogurt too. I won't play the entire song. Oh, come on. How did we Come on, get to the music. Sorry, I know I'm missing it by skipping through it, but this was not as good as I remember. I don't know. The one that I remember is white wine spritzer. A rod. It's the best type of math. I also need an excuse to not talk for a minute as I try to finish my breakfast. My granola is all soggy now. It kind of sucks. Oh my god. So yeah, I know. Unironically, not that bad. Ultra violent, yeah. Uh, so I want to figure out. Oh yeah, the AI named one of my variables scat, and I like. How do you not laugh at that? I just want to figure out what this code is doing before I actually use it, because I could just copy paste it, but like, no. Matplot lib func animation. I might copy paste it, but let's at least copy paste it knowing what it does, if that's what we're gonna do. Ooh, Arad, are you in favor of AI? I feel like math people are pretty split on it. Um, yeah, unfortunately I can't really show how I usually interact with AI on stream because I prefer to use a local LLM if I can. But that kind of eats all of your computer's RAM. And so trying to do that and stream is just not going to be good. You're cynical. Oh, okay. Yeah, I mean, I don't think like I AI is going to do a lot of good and a lot of bad at the same time, I think. Okay, I finally finished my yogurt. Chasing Claude the other day to resolve some bugs when I have my own code. Just compiling something for GitHub. Can't say you were satisfied with the result. Fair. I have had AI kind of crash and burn on some things, but for coding, it's been pretty reliable for me. Let me put my bowl away. 1 second. Okay. Make mistakes and make things up? Yeah. On type theory, I don't really have any thoughts on type theory because I don't really know what it's about. To our long path of reconfiguring shit, reinstalling WSL. Eventually gave up, went to reading the docs, found an alternative solution in 10 minutes. uh, type. Type? Type hype? Tape phobos. Formal systems classify expressions or mathematical objects by their types. Data type and programming. I'm a fan of data types and programming. But I feel like... What's the difference between type theory and set theory? That's my first question. Because this just sounds like set theory already deals with this question. What proof systems like Lean are based on? Yeah, I'm aware of Lean. I just barely started getting into this. Send you one of the first songs. Could be one of our pancakes. Okay, let me turn down the volume just in case it's loud.
I gotta take a little time to check the menu.
Pancakes at the disco.
I'm tired of eating cold brown flakes and dried old toast that's hard and crusty. I have enough of instant oats and plain
Amazing,
grapefruit
Slim.
that's sour and bitter. There's gotta be a better plate to make my morning feel much sweeter.
We're only halfway through, too.
In my life, there's been burnt scrambled eggs and cold leftover hash browns on plates. Can't stop now. I walked in this diner to change my morning life.
20 more seconds.
I wanna know what pancakes taste like. I want you to show me. I wanna feel what pancakes taste like. I know you can show me.
Slim, bravo. Encore. Should I add it to the stream playlist? I should. To have it randomly play once in a while. When you look at this, in set theories, you can ask if 0 equals R, the set of reals, and in type theory, you can't. Okay, I guess. What? Hey, not Chris. Type theory tends to be more synthetic, like Euclidean geometry versus analytic geometry. Type theory creates forced distinctions between things. Oh, yeah, I'm great at instruments like the cowbell or the triangle, xylophone. Any instrument that requires, like, you know, maybe like 80 IQ to play. Oh, hey, differences from set theory. But I guess I'm the only person who had this question. I've got a fever, and the only cure is more cowbell. Set theory has both rules and axioms, while type theory only has rules. They do not have axioms. That seems difficult to have anything in math with no axioms. Classical set theory and logic have the law of excluded middle. When a type theory encodes the implicit of and or, it leads to intuitionist logic and does not necessarily have the law of excluded middle. Element is not restricted to one set. Element comparing subsets and use with other sets. Terms generally belong to only one type. Number says functions using Church's encoding. Ratchet has inductive types. Okay. So yeah, I don't know if I have a lot of thoughts about type theory. It exists. I would need to learn more about it to like say much about it, I think. Okay. Yeah, I think that video, it probably does a very good job of explaining Dedekind cuts. That's when I feel like I couldn't really pay attention to that video because I at the time I had what Leo, Ming, and Reggie all in Discord and we were all like joking around and having fun, and so I was like feel like, oh man, I'm not able to actually try to learn from this video right now, but I was having a lot of fun, so um yeah. I do remember that a Dedekind cut is basically just saying that irrational numbers are least upper bounds for sequences of rationals. Um, init function used to draw a clear frame. Results of drawing the first item of the frames. Oh, so do we really even need this? Or in our situation? I want to see if we don't use it, if we get something that's fine. Args. Wait, so Fenvox, with your spicy coffee, how do you brew your coffee? Is it just like filter coffee? Do you have like a drip machine? It's a drip filter machine? Okay. So I'm wondering if I took like normally to make a cup of coffee, I take 15 grams of coffee beans. But for spicy coffee, what if I just took like 5 grams of coffee, just so I'm not like, I feel like I'm wasting my nice coffee if I put frickin' chili flakes in it, or red pepper flakes or whatever. How much water would I put through it? It's 1 to 15. Well, I usually do a little more than that, but 15 times 5. Why can't I do math? 30 plus 30 plus 15. 75. No, I mean, it would just be a plastic cone. I don't even own a machine right now. Hmm. With all of you regular coffee plebs behind. um, it's kind of annoying. You have to, with Funk animation, you have to go for a set amount of time. I don't think we need any of those. That's all just, well, I guess it wants the T-max. What does set offsets do? Well, okay, thanks. Sets the offsets. I couldn't have guessed that from the function name. What do the offsets mean? That's what I want to know. Global? Does frames equal float inf work? Uh, oh, for this parameter down here? I don't know. What does the documentation say? Int generator function or none? Or an iterable. Well, I don't know what this part means. Or none. A set offsets something that transforms like a set offsets. Thank you, Harad. How far something is set from something else. Set offset set off. That's a really helpful advice here. Thank you too, Jed. I need to build in. I mean, I guess the stopping condition can be me closing the window. I wanted it to like repeat though. That's what I have in my original thing. Once it goes off frame, like start over from scratch. Um, I'm wondering why the AI it put a comma here. Does update and init have to return two things, and we're leaving the second thing blank? Iterable. Oh, that doesn't look like a tuple to me. Tuple of one element? Why? It has to be an iterable. Okay. Okay, fine. That probably is. There's probably a good reason for that. Somebody disable the ability to turn off offsets by calling set off, set off, set off. Nerds. Freaking nerds, am I right? Okay. Well, that's not what I wanted to do. I just want to see what happens if we don't init things. You are global. Oh, why can't I just declare x and v outside the function definition? I mean, I did that in my original code. I think the AI wants to... Oh, I shouldn't have... Wait, I didn't delete it. Did I delete it? No, I didn't. It declares x down here. Then it redeclares x up here. I don't know. I don't like this. I'm going to leave it alone, though. If I just run this code, does my computer explode? X equals x plus 1. It does not explode. That's good news. Hey, Sandals. Hey, Roxra. Whoa, wait. Why did it come back? Oh, because, yeah, it looped back around. Sorry, this is running in a VM, and the only way for me to show Windows, I guess, or the only way for me to show this window for some reason, actually, I haven't tried it in a while. I have to use a weird way to capture it in my OBS, though, because it runs in WSL. Okay, so nothing bad seems to happen if I don't init. Init? I wonder if that's the intended place. So, like, let me show it again. I wonder if that's the intended place for me to, like, set up these two rectangles that are, like, different colors. Because that's where, how I'm representing, like, the magnetic field strengths. I don't know. It doesn't suppose that means it isn't getting set off, like, because someone is called set off, set off. It's just, the jokes just keep on coming. Okay, I also want to get rid of you. I feel like I don't need this line at all. Does my computer explode now? Cannot access the local variable x where it is not associated with a value. But I have x declared out here. I thought Python just kind of, it doesn't really have scope. I thought everything is just global. It needs to return an iterable, Jed, and that's how you make an iterable in Python of one object. It does now? I hate Python. I'm so confused about why I need that. Is this X? Am I overwriting the X I declare up here, though? I guess it doesn't matter. Does it matter? I feel like maybe. I don't know. Roxra, this is a little like physics simulation. It came from a question that Fenlux and I were working on Thursday. If you have a charged particle in a magnetic field, it's a constant magnetic field, but one half is stronger than the other half. What behavior do you get? You get this really cool spiral pattern, and I just thought it was really fun, and I wanted to make code to like simulate it. Doesn't capture something called global or local. It's being called from Funk Animation and got no clue. Is this creating a new X though, or is it still the same X that I know and love? It's X you share. Okay. I am very attached to my X. um Updating it in place. Usually do a simulation, write the data to a file, have a separate render script because it'd be funky like that. Yeah. I bet for um that's probably the best practice. This simulation is simple enough where it doesn't matter, but for a more complicated one, I can imagine that's better. It's okay, Mavort. That Python is so unclear to me because of stuff like that. Like with things like Java and C++, it's really rigid and it could be annoyingly rigid, but you at least know exactly where things stand. With Python, I never know where it stands. Um, okay, so the next thing I wanted to do. Oh, wait, so I get to work with the frame object here. Um, is the frames that I have within my update method an int or something? Is it just the frame number? Wait, update. I'm looking for update. Or the func. Actually, ooh, wait, okay. Because, um, the next thing I want to do is I want to add, like, every maybe second, just leave, like, a transparent dot that's kind of like, maybe every half a second. Just leave, like, a little trail where you can connect the dots of what the path has been. And maybe instead of going by the frame number, we could pass in the current time. Do we know the current time? I guess we don't. But we know the frame number and we know DT. So I guess we do need to, yeah. Okay. What am I going to do with that now? I guess we're going to do like an if. Sorry, someone's like banging something outside. Frame times DT. Say if I want to do it every half a second, do I need to multiply it by 10 and then do mod? Wait, okay, wait, no. Frame times DT. Hmm. My DT is 0.01. They built different. Also, what am I going to do underneath this if? I haven't gotten to that part yet either. Actually, we could. I'm from America. We could just mod the frame number. That would be easier to not deal with decimals. What if we like did it every 10th? 10 might be too low. Let's just start with 10 though. I think you built different. I feel like, okay, maybe the thing that bothers me, instead of having a global x and v, I feel like I should be passing them in as f args. Maybe that's the thing that I don't like. Or that's how I would like fix the thing that bothers me about this global thing. Hey, Sesh Kale. 9th grade now, been learning about Pythagorean theorem. Oh, nice. I'm glad to hear it. Pythagorean theorem is cool. Welcome in. If there's anything you want to like ask about, let me know. Path history dot append. I guess we want to record our x's. Hey, Chandu. Write a class where x and v are member variables. That's a good idea, Mavort. I never actually made a class in Python, to be honest. Well, I would still need to like create an object with that, and I would still need to get it into this update method somehow, right? Or update function. Chandu, this is like a physics simulation. Don gets class today live. True. Yep. Sine and cosine aren't taught in German schools. Have to teach yourself. Basically, Sesh, I would be very surprised if you never learn about that. Maybe you haven't gotten to it yet, but surely those are really important things. And I'm sure you'll encounter them at some point in one of your classes, but you have the right idea. If you have a right triangle, think of it the follow. And let's just call the sides A, B, and C. You know the Pythagorean theorem. A squared plus B squared is C squared. You're probably not going to appreciate them. I mean, you might appreciate them now, but I need to label an angle here. I'm going to call it Greek letter theta. Theta. The trig functions are really important for a variety of things, and the three fundamental ones are sine, and the trig functions, they take an angle as input, so it could be like 30 degrees, but generically we call it theta. Sine is opposite of the angle, so opposite of theta is B, over hypotenuse, C. Hypotenuse? I don't know if that E is supposed to be there. um, Cosine is adjacent over hypotenuse, so A over C. And then tangent is opposite over adjacent. Or, yeah, B over A. And, yeah, they're just really, like, already they're very important because they let you relate the lengths of the sides of a triangle to the angles within them. And these turned out to have all sorts of like other applications too. But yeah, I guess I'll stop there because that's what your question was. But let me know if you have anything else that you're like curious about there. If you're interested in math streams in general, by the way, there's a whole bunch of people who do this besides me. Phobos is here in chat. She's one of them. That's a whole list of people who I can like recommend to. I bet there's something better I can do than constantly redrawing the scatter. Actually, I wonder if I'm going to keep on overwriting the same scatter if I do this. I don't know. We'll find out. Wait. I didn't realize we're actually this. Are we draw? What the fuck does set offsets do? Is that actually drawing it? Or no, I think the funk animation is what's drawing it, but like, why isn't it scat.scatter or something? I don't know. I've never heard of 2Live Crew aside from whatever Slim has just said. So I guess the answer is no. Calculate a triangle using Pythagorean theorem. Squared the sum, calculated that. Give me a new triangle. You squared the sum. I'm not sure which sum you're squaring. I'm not sure your process is there, but you're having fun. That's good. I probably need to look at just scatter. Set. Oh my god, stop looking in the sidebar. Oh. Wait, okay, what does this thing return? A path collection. That's the thing that we're setting offset. Why is the word offset so on here so many times? I hate you so much. How about this? No! Don't bring me back here! What? What are you offsetting? Why won't you tell me documentation? Ask I probably should. Calculate a triangle, made a new triangle from it. And they're quadrilateral. Okay, fair enough. Okay. You know what? The best way to learn is by commenting shit out and seeing what breaks. Okay. Nothing happened. There's no animation anymore. The dot does not exist. That's so weird. Why are they called offsets, though? The naming and map follows coincidences between parts of it? Okay. So if I... Well... Okay. I think we want a different scat for the path. Like the historical path. So I wanted to have different historic scat. I wanted to have a different transparency at the very least. Maybe a different size. I don't know. I saw these math edits on TikTok. What do they mainly show? Because I want to learn that too. Looks very similar to what you showed here. I'm not on TikTok. I don't know what the math TikTok show. If you have an example of the math they were doing, I can talk about that. But this is like a kind of like a physics coding thing. There's math involved, but I'm not sure what you're referring to. I'm not using this function, but let's just keep things consistent in case I do use it later. Ooh. Do we need to return both these now? Probably do. How do we... Is it size? Or maybe, is it just S? Marker size and points. Aha! What's the default? Okay, thanks. Let's just guess. 3. Then alpha equals 0.5. Scat hist dot set offsets for some stupid reason. Path history. Let's hope that works. This is a regular Python array of NumPy arrays. Arrays. I don't know if that'll make things weird. Let's just see if it knows what I mean. Something weird is happening. I think my path history is following the point. uh oh. Yeah, I need a deep copy. Something similar to what you just showed where you opened up the program? I mean, just like a graph sesh? I'm sorry, I'm really not sure what you mean. Like, I would need to see what the TikTok is, because this is just like an animation. It could be a lot of things. Only the deepest copies here in Dawn Factorial. True. X dot copy. Oh, hey, it's kind of working. I mean, it is working. I just need to fix the color. Maybe we don't want alpha. I don't know if we're alpha enough. Maybe they can be slightly larger. Manim? Oh, maybe brassicles. Just like math animations? I don't know any Manim, though. Myself. Oh, wait, I need to change the color. That's why... Okay. I want it to be blue. And actually, the... Oh, no, it looks bad if the thing... Okay. I want the history to get drawn before the point. What's the point? So the point goes on top. Color equals blue. Color equals blue. And I think we probably will want alpha now. Maybe. Let's find out. Maybe that's too much alpha. Maybe that's a better amount of alpha. That's not a good blue. That's a bad blue. Why is there no alpha? Maybe I need more alpha. Less alpha. That's closer to what I was imagining, though. Oh yeah, Mavort. This is a problem that Femlux and I are working on Thursday. It's a charged particle in a uniform magnetic field, but there's two different values for the magnetic field in each half of the plane. That's why there's two different shades of red. And so you get that kind of cool spirally shape. And I just thought that was really fun, and I wanted to see it animated. And I'm getting close to what I was imagining. Hopefully I don't need an account to see this. Okay, I don't care. Oh god. Oh, okay. It's meant to be complicated. This is an assault on my ears, though. um, but yeah, Manim is a library you use to make math animations with code. I think specifically in Python too. Um, and Bresco was saying that's probably the thing that they use there. They probably actually use someone else's animation. um, is that what you're talking about? Okay, you know what? I feel like the AI has shown it's clearly better than me at this, and I should just use its original code. Yeah, what I'm doing doesn't use that same thing. Oh yeah, I want a better blue. Skirt. The proud man counts his newspaper clippings. The humble man his blessings. That's not a bad fortune. I guess we want cyan. Wait, that's a repeat for. Oh, I don't remember it. Wait, what? Yeah, Mavort. That's what I use for this calculation here. I did MA equals QV cross B, and I divided the M out. I think it doesn't like something about me returning two objects here. I think I need to do that? Maybe? Are you happy now? Nope. Suddenly traveling to new place leads to great transformation. Ooh, that's a good fortune. Machu Picchu? That'd be sick. I just saw a video from a YouTuber I like where he went to Peru and he had a really amazing sandwich and some really cool looking coffee. Um, now I so it's something about the init function is fucking up. Well, it looked amazing. I don't know if it was amazing. I don't like this cyan color either. Mavort. Oh, yeah. I like changing individual colors though. Something to do with line 61. Uh Yep, it does say that. I don't know why it's complaining about it now, though. It was fine before. Should we be treasure hunters? I feel like we'd be good at puzzles, suck at physical stuff like jumping ledges and climbing vines. That's kind of the problem, Skirt. If there's like a giant boulder we have to run away from, well, let's say I would trip you, but that wouldn't really help me run away from a boulder. If there's like a bear that was chasing us, I would trip you to buy myself more time. A boulder, I might trip you for fun, but that wouldn't really help me. Um, why do you hate me, Python? What about snakes and other venomous animals guarding them? I mean, you just get some shin guards. It doesn't like what I'm returning, I guess? Played way too much Uncharted speedrun? Oh, you did say you were doing that, right? Hey, okay, that fixed it. When in doubt, just randomly make it an array. I still don't like this color. See, now this is a nice blue, but I was getting this blue. Oh, because it's tab. Haha, that's why. Okay, so I do tab blue. Blue. Hopefully that works. Okay, that's a nicer blue. You like teal? Uh, how does teal look? Oh, that's not bad. Yeah, skirt. I don't know how, but I can figure it out. I assume that we're gonna come back to it and at least do that big arena place at some point anyway. I don't know if there's more achievements, but uh okay, Sesh. I didn't realize you meant the actual thing that was on the graph. I thought you just meant like the animations. So yeah, I would tell you calculus is kind of two big ideas, two and a half. Uh derivatives and integrals. And normally you learn integrals second and derivatives first. I mean, it's lurking in the background, Arad. They just updated their website though, and it looks a lot worse in my opinion. And that the kind of half idea is limits. You need to understand limits to understand both of these. Yeah, I don't think Jake enjoyed that last stretch of the game for sure. Yeah, I'll make a note, and once I turn off the stream, I'll look in the files and send you the save regardless though. Um, yeah, so to get to calculus, you don't technically need that much. You should just kind of have a good familiarity with like algebraic manipulations and some of your basic functions like polynomials, trig functions, I guess like logs and exponentials. Um, but yeah, as Arad says, I do have a favorite website uh, for calculus. It's very like yeah. So this is how it looks now. It's really bad. I think I missed their red. Um, it's very focused on like problem solving, and it doesn't go very much into the theory at all. But I personally kind of like that approach, especially for a first timer. Um, but yeah, I would stick with the stuff you're learning now and kind of stick with it before. If you're really eager to learn calculus, you can try to learn now. But if you're being disciplined, I would stick with the stuff that you're doing now and kind of like build up to it more naturally. It is easier to study for at least for me. It's easier to study things with motivation though. So if you do want to skip ahead, like go ahead and try. Worst case, you just go back to the stuff you're working on now. If you want something a little more like a traditional textbook, I recommend this website. Um, it has real university textbooks that are free and legal to use. So it's a really nice resource. They have a good few calculus books. Yeah, if you're excited about math, it can definitely help to see like what's coming up. Papaya whip. That's such a fun name for a color. It doesn't look that exciting, but papaya whip, that's a fun name. No worries, Sesh. Was puzzle ballet designed for more than 4 people? I mean, yeah, they're not designed for more than 4 people. They're designed for at most 4. Um, yeah, so those puzzles were not that great. Especially that music puzzle was terrible. I think I don't know if there's something obvious that we were like missing there, but like if the solution is really just memorizing 10 different little bits of music, that's a pretty terrible puzzle. AMS, okay. I'm insulting colors. It's what I do. Burleywood. It's a fun name too. You have any colors that you feel their names don't match the color? That's a fun question, Papadoria. Do I feel like that? I mean, this is probably a good reference to use. Is there a name that doesn't match the color? I don't think so. We're kind of... Not because it's impossible, but like... The names themselves, they're either made up or they're related to some real object that has that color. Yeah. Mint cream looks like it's just white. I saw mint cream somewhere. I don't remember where it is now. Here it is. Yeah, that does just look like white. Burgundy to me is so bad. Burgundy seems so brown. Oh, burgundy might be a good one. Burgundy. It does feel like it should be brown. Yeah, okay, yeah, burgundy's a good shout. But it comes from a French word, and you know the French are probably just messing with us. Same with Owl's Blue. Yeah. Your go-to color when you want boring. Why do you want boring nails? XKCD colors? Is this something different than the comic series? Wait, no, this what? I didn't know they had this. Chartreuse? Why is it green? I have never heard of that one. You can do two things. I guess so, Arad. I have no intuition for what chartreuse should look like. It reminds me of matcha, which makes me enjoy it. It's like a deep blue. I don't know about that. Nail art takes too long. The heat spikes make me go wah. That's fair. Abort. Let me see how it looks. Okay, this dark mode I can handle. Sometimes dark mode, it hurts my eyes. That's why I usually use light mode. This dark mode is okay. It reminds me of matcha. It's not exactly the color matcha. Sorry for the... Wait, what? Ah! Okay. Please change. Why aren't you changing? Okay. Shrek Swamp Water? Well, that looks delicious too. It's genius, Arad. And I mean, I could do it selectively just to the window, but you're right. It'd be better if I did it to the whole stream. Okay, what was I doing again? I really need to clean this code up because it's gotten really messy now. God damn it. Okay, let me just see how the thing looks, and I will, and then I'll do the push-ups. I think I'm going to increase the Y limit. Oh, you know what I wanted to do? I wanted to make the animation stop once it gets off screen. I did want to do that. I don't know why I said that twice. I need to change the frames to none. Wait. Was this still broken? Oh my god, I didn't fix it. Okay, fine. Let's do the push-ups. Dogs are breathing into your ear. How did this get here? The hell? Because I pressed my keyboard. I don't know how to please you in it. What do you want from me? Iterable of artists. Should it be a tuple? Is that... Should I not be doing an array? Is that the only thing? Well, it's complaining on the line before. I think. What's wrong with you? Well, it doesn't like line 61. That's when it's calling out. I could do that on 78. I don't... That won't fix the issue at hand, though. Def not Dexter, hello? Thank you. Okay. What if I just got rid of you? Are you still complaining? You're still complaining. From 1 to 10, it's my lucky day. 6. So it doesn't have to do with the init function itself. It's the set offsets. It's n by 2 or it's 2 comma. I gotta ask. I don't know if I changed something or if the AI was just wrong. You're gonna dip out in 6 seconds. Okay. Uh, if I just don't use the init thing at all, which I don't know what its purpose is anyway, the code works fine. Uh, See, I really don't know why that's there. It's even at 4 a.m. Probably sleep. It's very early. Um, a comma between the square brackets on 61. Ooh. I feel like it's gonna mess it up. It already does not like that. Yeah, I don't know about that. Oh, just putting it... Okay. Nope. Crack a joke, I'm bored. Your face. Hey, look. It's light mode again. Didn't you guys miss this? I don't know. I probably need to change the system default, but I really don't want to do that because it's gonna... I don't want my system default to be dark mode. I'm sorry. You're just gonna have to deal with the flashbang. um... Yeah, they also did set offsets. And so like Bobo said, it's just a really bad name, I think. Uh, do they? I guess this is probably their init, or that. Well, that's their init for the class. Self.scat. They have actual data though. I assume the issue is that we don't have actual data. I don't know. I did do the fundamental thing that I wanted to do with this code. Um, I don't know if it's particularly exciting to watch me try to like do all these small tweaks. Maybe I should just like switch gears to something else. The aspect ratio of this isn't quite right now that I up the Y limit bit. It is kind of funny because the way that I'm simulating it, it's not like stable, I think, like I guess numerical stability. Like it should not be drifting right in the way that it is here. Um but I think because I'm just using this kind of like first order approximation, basically, I'm getting it's kind of gradually drifting off to the right, which is something that could be improved on, but I don't know if I want to bother. 9 plus 10, 21. It probably is drifting left too, yeah. Have I got an A level in math? Are you talking about like the A levels in the UK? I don't know what you mean. Here's which path you create. Prove 0 to the 0 to the 0 does not exist by finding two unequal paths of the multivariable limit. Oh, didn't Black Pen Red Pen just do a video about this? I didn't watch it. Yeah, it might be getting wider as a whole, Frescals. I wasn't paying attention to the left. Yeah, I tried to figure that one out. Oh, Papador, you asked a question a few days ago in the Discord, and I said I'd think about it more, and I didn't. Yeah, I'm American. I have a master's in applied math. Yeah, velocity is constant. Magnetic fields do no work, so it shouldn't speed up or slow down. Yeah, Papadori, which one would you be more interested in hearing about? I could talk about both. But like, which one would you want to start with? Um. Oh, really? To the integral one. There's a simple one. Let's see. That's the setup to the question. This is the actual question. Difference between math and applied math? Just the parts of math that you focus on. Applied math focuses on like, especially on like differential equations, numerical analysis, intersections of math with other subjects like economics, physics, biology, and regular math is kind of any other part of math. Um, so my thought about this was that there's probably some way to write this as a derivative and use fundamental theorem of calculus. Because that's the only way I could see this being equal to f of 1. We have to get a derivative somewhere in here. Um, if we took the derivative of this thing, now you're doubting it's this simple? Okay. Maybe this actually doesn't work how I hoped it would. The thing the keeper, I think, is this piece, but in order to make that match that, we've got to do this. And I think we're going to get something messed up, because this term, I'm not going to know what to do with now. Oh, wait, and the x in front kind of messes everything up. Yeah, I don't know if my idea actually works. Dexter, it's okay. You don't need to do that. Right. I think I need to think a little more. I need to think of like, what is x to the y plus 1 f of x? What does this derivative look like? I need this to like pop out of whatever thing I take the derivative of. That's how I should be thinking about this. This is what I want. This I don't know what to do with. The answer, at least you have, works. Okay. So we can say y x to the y f of x is equal to the y plus 1 f of x prime. You don't press recommend to live crew? Okay. You're saying just a change of variables, def not Dexter? I don't know if that would do it. I think we'll still have f of 1 on the right side. Is it a change of variables? Really? Huh. Doesn't that mess up this x too, though? Like, you need to divide that out? The function f of x equals x to the y converges pointwise to f of x equals 0 for x between 0 and 1 if x is equal to 1. Oh. Sure. Yeah, Mavort, that is a maybe that does indicate that I'm on the wrong track. Because I was trying to understand like why this equality is true in the first place, and maybe my idea isn't the right idea. The thing I don't understand about the substitution is like we can say x equals like nu or whatever, but that doesn't change this f of 1 over here, I don't think. You know, I guess integration by parts is maybe worth thinking about too. That never really crossed my mind. Why pi and why this function? It's rotated. Uh, if you're only just learning Pythagorean theorem, Sesh, this is zooming way ahead. Um, you're you it would take way too long for me to explain everything that's going on with that problem to you. But if you're willing to take it for on faith that the graph y equals sine of x looks like this, going off in both directions to infinity. This point right here is minus pi 0. This point right here is pi 0. If you integrate sine from minus pi to pi, these are x coordinates. And it's the area under the curve for sine from minus pi to pi. And area for an integral is allowed to be negative. So this part counts as negative area, and this is positive area. And sine is symmetric, so like the negative and positive just cancel out, and you just get 0. That's the simple version of what's happening. I'm not sure how you get to f of n in this mess crouching jab. Ignoring the validity of the equality real quick isn't the question. It's just asking for a function transformation. Oh, a transformation like that with f of x. Yeah, that's probably that. Okay, that makes sense. The integral scale in order for limit to converge to a constant. Yeah, okay, my idea is too complicated. Yeah, you take g of x equal to f of nx, right? I'm trying to figure out if it's nx or x over n. Ultra product said nx. G of 1 equals f of n. I guess I'm confused. Does that mean g of x over n equals f of x? How do we actually apply it to the integral? I don't actually know how to use the substitution. I can see it's something like that though. G of 1 is f of n. Oh. Wait, that made sense for a second. And now it doesn't make sense again. Z equals x over n? Maybe that'll help it make sense. Uh, 0 to 1 over n? But isn't this still equal to f of 1? That's what I don't understand about, like, we need to take a, like, we need to get rid of the f. Just write the letter g. F of nx equals g will always exist. Is that it? I think I did it. That still feels weird. Okay, I think that's how it's supposed to be. Yeah, crouching jab. I mean, with the x equals or z equals x over n thing, there is a, like, that chain rule type of thing you have with subs, but that wasn't the issue. Think harder, not faster. Yeah, I guess it's really not that, it really isn't that difficult, but it's weird to think about. Incorporate integral calculus in my math lesson at school. Currently working. Uh, yeah, Sesh, you can't really. Like, it. It's like you've just learned how to play checkers and you suddenly want to play chess against a grandmaster, Sesh. That's maybe a little bit too strong. It you do seem really interested in learning calculus. So if you want, just jump ahead to an actual calculus resource and try your hand at learning it. Um, you'll probably realize you need to go back and learn something earlier, though. So there's no harm in trying. I wouldn't try to mash what you're currently learning in with calculus. That's just going to be very messy. But if you really want to learn calculus, try just doing it and seeing how it goes. What I can recommend for sure is 3 blue 1 brown. I think you're actually probably a great like this is a great case where 3 blue 1 brown is a great resource for you. I'm using the word great a lot. He's really good at conveying the intuition of the stuff. And the intuition is a great place to start in learning this. But yeah, if you really want to skip ahead and start doing calculus, I would probably start here. You're probably, and like I said, like, you're probably going to find that this is a lot to follow, and that's okay. if you need to go back and keep working on the fundamentals, that's probably what 99.9% of people would need to do in your shoes. So there's no shame in that. Um, hey, Winklebot. Serious conversation about you're not the first person to criticize my use of light mode, and I'm sorry, but I hate dark mode. Um, I mean, I mean, we're allowed to assume the initial relation, and it's just a change of variables. Um, so Papadori asks a separate question. Another like just for fun one. I forget exactly what the phrasing was, but it's from a recent black pen red pen video. I think it was XYZ goes to the origin. X to the Y to the Z. And you can find different paths to make it not converge. Nothing wrong with eating a bag of rusty fish hooks either. Yeah, I'm sorry to the people who hate it so much, but I prefer light mode. The fact that my journal plus plus that you're looking at right now is in dark mode is already like a concession because so many people like dark mode. Oh, sure. You know, is this how you note it for multivariable limits? I don't know if I've ever had to consider one-sidedness. Oh, no. That's not how you do it. You say x greater than 0, y greater than 0, z greater than 0. Um, well, the simple thing to try is just setting all of them equal to each other. And then trying different ones. Well, can we do or equal to 0? Well, I guess that's what the limit is. Hey, Quantum. I don't know if that's actually good or bad. Uh... This part up here, well, from the right. Doesn't this depend on how we evaluate the limit? No, it doesn't. That's 1. Ooh. There's an issue of ordering, doesn't it? Isn't there? Wait, no, or am I... If we evaluate this first, then we get x, then we get 0 to the 1. But if I evaluate this first, we get 1 to the 0. So yeah, we do have an issue. And the same issue is present here. Oh, okay, you fixed that. No, Winklebot. You're thinking of like x squared cubed, I think, like in parentheses, and that is x to the 6th. But if you have x to the 2 to the 3, that's x to the 8th. Or I guess like if you have parentheses like that. It is a confusing thing. Okay, so that evaluates to 1, that evaluates to 0, 0 to the 1 is just 0. You demand better notation? you're not gonna get it, unfortunately, when it comes to math, but I appreciate that demand. The Dawn function. Okay, so we can get 0 from this limit. Can we get anything besides 0 from this limit now? Dom 3x is x to the x to the x. Yeah, how can we squeeze a 1 out of this? The case where y equals 0. It's probably a good thing to consider. Oh, yeah. Wait, is that working? Because this just is 0, isn't it? Oh, okay, yeah, sure, and that's what we want. Okay, good call, Ultra Products. Vibov, it's the new California Republic flag from the Fallout games. Yeah, we can, Winklebot. I wasn't doing it. Like, I was just, I done that enough times in my life that I just kind of have it memorized. That this limit equals 1. You prove that with a L'Hopital's idea, though. You say, x to the x is equal to e to the x ln x. The limit can come up into the exponent, and then you can do L'Hopital's on that. Is it a case where x equals 0? Yeah, fair. That's probably simpler. Hey, Leo. That is weird. ln one. I mean, Black Red Red Pen does do crazy stuff just for fun. Yeah, Bretzkels, that is one that people like to argue about. He has a video where he integrates cube root of tangent. I think it's cube, or maybe it's square root of tangent. Just for fun. And then he takes the derivative to prove that he did it right in a separate video. Oh, he probably did Winklebot. That sounds right. Yeah, I don't want to read this much. One video on his Patreon where he did like the integral 1 over x to the n plus 1. Some huge n took the derivative of it to prove it. Yeah, he is crazy. Yeah, I prefer light mode. People have been complaining a lot today about it though. I prefer light mode though. And actually, yeah, this is one of the dark modes that I just can't do. A light mode complaint counter. We could. It'll feel a little like passive aggressive though. Um. Okay, I am curious because I to hear your thoughts about like the counterexamples. You've been talking about this a lot recently. I don't want to read the entire thing and have to deal with like measures though. uh. No play with limits as we know them. Galois had no notion of a group. Definitions came last. Definitions do not survive. Counterexamples. Counterexample tell me something is off with the theory or with the objects that we've chosen. Classic counterexample presented in topology. Counting space of the path that isn't connected. The full and abridged class of topological spaces is inconvenient, often specialized to other classes of spaces for our purposes. Subject of the recent work by Dustin Clausen, Peter Scholes, about fixing the inconvenience of topological spaces, similar simplified line. Considered a full subcategory. Okay, yeah, I'm sorry. I don't even know topology. I don't know this stuff. Okay. Industrial domains in Rn determines map between topological manifolds. We can tell the difference between XR and X. It can often be removed. I mean, the counterexamples are the motivation for why you need to define your definitions a certain way, though. I don't know, Leo. I still don't understand. Like, you seem uncomfortable with counterexamples for some reason, and I feel like you're saying exactly why we need them, but you're still not comfortable with that for some reason, and I don't understand why. Get it when the normal light mode has some nice text box red or blue. Dark mode, they're just gray. Happens with PDFs from books sometimes. Waiting for a game dump. Did an integral. Holy Ride. Love these bad boys so much. Oh, hi syntax. Column, it sounds cool. Wait, oh, hi syntax? Wait, Sandals, are you syntax with a new name? Oh, I thought you were someone new. Okay, you're sandals now. Bye, Bob. I just recently earned a master's in applied math. It's not sandals. I don't know who you are. ELI 5 is sheaf. I hear that term used a lot. I don't know if it has an ELI 5. Did Leo? Sheaves are what we use when functions between sets are simply enough. We generalize not enough? We generalize to have more flexible domain while still having a good amount of continuity. Simply not enough? Okay. But if our front question in DC, okay. Sandals? This is what I thought I would see. Oh, a beer. Ah. That got I when that got auto-modded, I was like, wait, what context are we saying this in again? Yeah, Oreos. Okay, this checks out for syntax. You could put your feet in this. Yeah, that's very true. Your name is Santeri. Sometimes people call me Sandals. Oh, okay. Sheep stuck in toaster. Mavor, maybe one day. I've graduated though, and I'm no longer a student, so I would need to apply and get into some school. And I don't know if I want to go through that process again. I've tried a few times to apply for PhDs, and it just hasn't worked out for me. And it's a really long and expensive process that I don't know if I want to go through again. Solve Laplace equation inside the unit sphere. Oh, Vipov? No, I will not like it. I've tried it before. Um, is this like spherical harmonics? Is this where they come from? I don't remember. I guess we'll find out. Okay, so unit sphere. We need the definition for the Laplacian in spherical. Wait, I'm a little confused. Oh, using axial symmetry. Okay. I was wondering why our separation of variables only had two variables. It's nice. Okay. Presumably we're doing the mathematicians convention for spherical coordinates too, not the physicists. Physicists switch theta and phi. Wait, which convention does Wikipedia use? They don't say. I think this is the math convention. Uh, let's just trust that it's the math convention. I forgot Wikipedia does that. This is to switch smartness for dumbness. Boom, roasted. um, finish your studies, learn math on your own for fun. Yes. Are you still taking courses somehow? Not formally, no. Right now I'm applying for jobs. Uh, I'd like to learn. I'd like to do some a lot more self-studying, but just all my energy is going to job applications right now. Um, but yeah, like just studying out of textbooks and like MIT open courseware and stuff. I want to do more of. Emphasis. No, before in my experience, they switch theta and phi. I believe you could teach me how to fart super hard. I don't know if you can teach me to do the others. So axial symmetry, I think that tells us this term is equal to 0. There is no variation. Ooh, is that what that? Well, it must be if we can. Yeah. Wait, Mavor, I think you're doing the physicist definition or like convention. Uh, the convention that I'm used to, sorry again for the light mode, is theta is the angle in the xy plane and phi is the angle from the z axis. And that's how I was always taught in my classes. But maybe it does vary by the country. But at least in America, we have this weird split. Maybe other countries have it figured out better. Okay. And I think other than that, this definition of Laplacian is good to go. So we know 1 over r squared. Should we do these product rules now? We'll wait. It's equal to 0. You see phi as 0 to pi going from top of the sphere down. Theta rotates around the z-axis. Yeah, that's what I usually see too. Why not keep the same convention? Theta as polar coordinates, then choose a new variable. Yeah, when go by, and that's the math convention that I'm used to. Physicists, for whatever reason, uh, I think probably just to mess with mathematicians, they reverse it. Okay, I think I've done this before, actually. Actually, yeah, don't you get, whatchamacallit? Sturm-Liouville out of this? I guess it comes out to Legendre's. Actually, I don't know what Legendre's equation is. I guess we'll find out. Oh god. Okay. Editing, Devil, and Vibov, you guys are having your own conversation and you're going into not English. Can you guys uh take your conversation on a different platform if you're gonna not speak English, at least? It's an all beat PvP? Oh, okay. Just give us a few minutes. Uh, no. You either speak English or talk somewhere else. If I can't read what's being written in chat, that's a problem. Uh, I guess I should have just done the product rules. Okay, so 2 over r. Don't do the product rule yet? Okay. We can get rid of the r squared, can't we? On the outside? Just multiply it away. Ah. Um, it's r prime big theta. Sine theta. R big theta prime equals 0. Um, it's the name of a function, Winklebot. There's a technique for solving certain types of partial differential equations called separation of variables. And we know that, like, the function that we're solving for u is going to be a function of r and theta. And differential equations are all about kind of educated guessing. And a really good educated guess is creating separate functions for each variable, basically. And so we're creating an artificial kind of big theta function to represent our like theta variable. That's really funny, Mavort. The Germans have it figured out, apparently. English speakers are over here confusing each other. Hey, the Gen. Uh, so I forget how this works. Do I really not take the derivatives still? I really want to take the derivatives. Divide by r and theta, and then separate. Oh, sure. That theta can come out, that r can come out. When it's the, yeah, that's funny, Mavor. Hey, Kailash. Okay. Yeah, it has been a few months since I've done this. I forgot that's what you do. R squared, r prime. Okay. This is a piece that depends only on r. This is a piece that depends only on theta. And so we're going to require they independently equal 0. Because there's no way they're going to cancel with each other. Yeah, I remember doing this now. Thank you, Kailash. Okay, so that r goes away. Should equal lambda. Oh, they just equal the same. Oh. You're right. Shouldn't one be negative lambda, though? If we're still trying to use fucking foot-pounds? Yeah. Purely conventional lambda versus minus lambda. I just feel like they should have opposite signs as my issue. Let me pull up one of my homeworks, if I can find it. When did I do this? Seems weird to me if they have the same sign. I don't remember when I did it, though. Hey, King Assassin. Is it? Alright, maybe I'll just send it. See, there's... Yeah, this is partial differential equations, which Calc 3 is kind of the minimum. It's differential equations plus Calc 3, basically. Okay, what am I doing? PS over root KM? What the hell? Ultra products, uh... I'm thinking about it. I'm getting kind of annoyed at this. One should have a negative? Alright. I'll just add it. So, the thing that's gonna... like, I'm supposed to integrate each side in terms of r and theta, right? But how do I integrate the big R or the big theta? Alright, bye, Bob. Legendre's equation. Okay. Well, so, oh, like this. Oh, I forgot that was in my title, King Assassin. I kind of set it down for today, for this stream. I don't have it up anymore. So I'll just show it briefly. It's for a charged particle in magnetic field. It's a constant magnetic field, but the right half is a different value than the left half. Yeah, the one that Fenlux and I did the other day. It's not quite right, but I got it close enough for me to want to put it down. Basically just Euler method. Yeah, they don't look like semicircles because the aspect ratio is weird. Like the axes aren't scaled quite right. Um, and it's also the method that I used to simulate it is not very stable. And so if you looked closely, it was actually like drifting outwards. The circles weren't all the same size. And that's because of the way that I was solving it, basically, numerically, or simulating it. Yeah, I was basically just doing Euler's method, like first order stuff. So you need to really like find time step for that to not be bad. The master of us all. Yep. uh, we need to do a change of variables on this right equation to make it look like Legendre's equation. It does look pretty similar. Uh, I mean, a Pythagorean identity. Well, no, it wouldn't. Collar cone. I guess I am, kinda. How are you doing? U equals cosine theta. So 1 minus u squared is equal to sine? Or sure. I don't know if we need that. Wait. How do we get rid of the... or we need to translate the derivative into x then, don't we? Or u? How you handle the boundary itself if the particle ever ends up there. Momentum will keep it going. I mean, it would just keep going, but off screen. Oh, you mean exactly at x equals 0? I mean, the problem doesn't quite define what happens at x equals 0. I don't have... The magnetic field is essentially 0, exactly at x equals 0. Numerically, it will never exactly be there anyway. But its momentum will keep it going. Like, it's really not going to change anything. Even if you did have some crazy strong magnetic field exactly at x equals 0, it would only affect, like, the very beginning. Like, when the particle first starts moving exactly from that point. In the simulation, it would never hit 0 again exactly. I don't think. Um... Well, U was a bad letter to use, actually. Um... Yeah, it'll just propel it... Well... Yeah, never mind. Yeah, I guess it's true, Found. So you could think of it as like a third region between the two that you make infinitely small with zero field, where the particle's just momentum keeps it moving forward. Uh, I'm still very confused how to use this substitution. Because this big theta is a function of small theta. So are we getting like an arc cosine of x or something as its independent variable? But that so big theta, a function of theta, is saying is equal to... This doesn't make any sense. Use a rule you can buy at a hardware store? What? Like, if we want to do a change of variables like this, we have to figure out what it means to take a derivative in terms of x. And big theta needs to change too. The wrench rule. Chain, oh. Oh wait, okay, you're trying to work backwards from the Legendre equation. Okay. I still don't know what to do with the d by dx, but I'll ignore that for now. I guess that's what you're saying about the chain rule. Okay. Well, what the heck does this mean, actually? For solution to the Sturm-Liouville problems of the Jondor polynomial p of x, then theta equals p of x. Yeah, King Assassin. I'm not very experienced with like these special differential equations either. They seem important though. Like it's good to know. You've never seen these atomic orbitals. Yeah, I've seen these in like a chemistry class. And yeah, the first thing I said when I saw this problem is that this is about spherical harmonics. So that's what I'm expecting the answer to be. I'm just struggling with the chain rule here. I'm really bad at chain rule for stuff like this. Um, dx d theta with dp dx. You're just writing it wrong? Hey Ming. Yeah, this is a question from Breskels in chat, just for fun. Solving Laplace equation on the unit sphere. Hope you're doing well, Ming. So yeah, I know the answer should be like spherical harmonic functions. I'm trying to get there though. dp d theta, d theta, dx. Like that, I guess. Look, I had a problem with sorts similar to some parts of this in my E&M class. To no PDEs, but yeah, E&M is actually secretly PDEs in a lot of ways. Maxwell's equations are just PDEs. It's kind of fun, especially if when you're learning about like electrostatic potential. You're basically solving Laplace's equation. It's equal to theta prime. You can do some subs for what you know dx d theta to be and what dp dx to be. PDE's nuts. Hey Fluffy. I need to message you about the epsilon delta stuff. I got distracted this morning, but I meant to message you. But let's try and schedule something for this week. Which step am I at? I'm trying to take the angular equation and express it in terms of Legendre's equation. I'm just struggling with the change of variables right now. Because I always struggle with changes of variables in differential equations and like the chain rule and stuff. 32-page paper for my PDF course entirely based on Maxwell's equations. Oh, wow. Yeah, that's the first step. Wait, so, okay, so this d by dx out here, I guess we would do d by d theta dx. The 1 minus x squared. Just saying big theta equals p of x doesn't make sense to me. Yeah, this is the dE with respect to theta up here. And this is like what Wikipedia has as the generic Legendre equation. And so I'm trying to connect these two things with that x equals cosine theta. One minus x squared sine squared theta 1 over sine x dp d theta. I mean, once I have p in terms of theta, I think it'll be fine to say p equals theta, but feels premature to say it where I'm at right now. Oh, then the minus sign out here canceled the one out front. Wait, x, that's a theta. Ah, what am I doing? That's a theta too. d theta equals dx, or d over dx, dx d theta, right. Dx d theta equals minus sine theta, right. Ming. Imavort. something like p of cosine theta or something, right? Yeah. Studying math or physics, you'd be slightly off kilter. Differentiating factor is about pureness of heart, is it? um, Dang it, I keep switching x and theta. Um, Back up a tiny bit? I don't know where you want me to back up. I think I nearly have the right thing. This is pretty much what I have right now. And it's almost exactly correct. The negative sign, I didn't express it very well in my work. The negative sign here, there's an canceled with the negative sign from this thing. Can you Discord? I guess so. I guess we could do a Discord call. Yeah, I guess, Ming, whenever you're ready, just call me on Discord. I think that'll be the easiest thing. Okay, here's Ming.
Hi, Don.
Hello.
Can you hear me?
Yes.
Hi. Can you hear me? Yes.
There's an echo,
Great.
though.
Great to hear you. Yeah, so
Great to hear you.
Yeah, so
Sorry, I think I
there's
can hear my
echo.
own stream through your mic.
Yeah. Hang on. Let me just because it's odd because my headset is broken. It's not working anymore.
Oh no.
So I'll just mute myself on my PC and I'll hear you from my mobile. So this way, perhaps that's better. Actually, I had the same problem when we were doing the Sony review. We'll have to. I have to figure it out before the 29th when we do the marathon review thing.
Yeah, no worries.
Actually, here, is this better now? Is the echo gone?
I think it is. Testing.
Hi Don,
Yeah.
can you hear me?
I
Is the echo gone?
I can hear you, and I think it's gone. Okay, perfect.
I'm just struggling with the chain here.
Oh wait, now I hear it again, but it's like backed up. Or I just heard you talking about the chain
Hi.
rule a few minutes ago.
Hey, can you hear me?
I can hear you.
Can you hear me? Do you have sound?
Yeah.
Can you hear my voice?
I hope you can hear me. Yeah, I can hear you.
Hello?
You not hear me?
Yes, I can hear you.
Oh,
yes, I can.
okay.
I can hear you.
I can hear you too. Then okay.
Yes, I can.
I think it's working.
I can hear your stream.
Oh, through the stream. Okay. Well, Blag will be weird.
Yeah, please send me the question though. Can you send me the
Oh, sure,
question
sure.
through your Discord? This way I can. Just send me the question, like the. Yes, that'll be great. Awesome. So here we're assuming axial symmetry. So there's only one angular variable.
Mhm.
I see. I see. There's only one angular variable here.
Right.
Do you have the Laplacian for the spherical coordinate?
Yeah, I'm
Do you
showing
have
it on the
the
stream here. I'll send it to you too.
Do you have the Laplacian for the spherical coordinate? Okay. There's
And so I
no
took the
image.
phi component and set it equal to 0, the derivative with respect to
Right.
phi.
So I'm just having dinner.
Oh, nice.
I don't know why my stream is lagging. Because sorry.
It's okay.
Okay. So now I can hear you because I was actually listening to the uh, the earlier part of the stream.
Oh, okay.
Sorry about that. Sorry about that.
No worries.
So first, do we have the Laplacian for the spherical coordinate?
Yeah. I pulled that from Wikipedia and I set the derivative with respect to phi equal to 0.
Okay, so what's the angle here? Do you know the convention?
Oh, it's the math
Do you know the convention?
convention.
Like
So
theta,
theta's in the xy plane. Phi's from the z-axis.
assuming axial symmetry. You know there are like two angles for the spherical coordinate. And I know in math and physics, the convention is flipped.
Yeah. I'm pretty sure I have the right one. The person who asked the question confirmed it.
Okay.
It's using
Okay.
the math
Oh, yeah. So
convention.
there's the Laplacian. Okay, I see the Laplacian on the screen.
Yeah.
So the first term is purely radial.
Hmm.
And we want to do the separation of variables, right?
Yeah.
So
That's what I have
u
down
equals
below.
r and theta. Sorry, u of. Okay, okay, okay. You already separated the variables.
Hmm.
It's-
And so, yeah,
And
so
we're
the
just
angular
worrying
equation.
about the angular differential equation. D over d theta sine of theta times big theta prime equals minus lambda big theta sine of little theta. So we want to convert this into a Legendre equation. So that's the problem. So
Yeah.
that's the right now.
And so I have my angular equation that I'm highlighting on the stream.
The angular equation should be an Euler equation, though. So do you have that?
I
Like
have to look up.
the Euler-Cauchy type?
I don't know that by name. Let me Google it.
Okay, I see your radial equation, d over dr, r squared, r prime equals lambda r.
Right.
So if we just expand the left-hand side using the product rule, you got 2r r prime plus r squared r double prime equals lambda r.
Yep.
That seems about right. That's exactly a Cauchy Euler type because r squared gets multiplied by the second order derivative. R gets multiplied by r prime, and r itself has no has no variable factor. It's just a constant.
Sorry.
So let's try if we can simplify this a little bit.
Okay.
Because you can actually, I vaguely remember you can restrict the form of lambda. So for this type of ODE I'm kind of setting aside the ODE for theta right now.
That's okay.
Just purely worrying about the radio one. Okay, sorry about that.
No, I assume
So
I'll do
let's
something
try
both. So
big R equals R to the L. L is to be determined. L is actually
okay.
L is now a free variable. We want to express lambda in terms of L.
Okay.
Just substitute. So this way we get 2R
Oh wait.
times
We
L
need
R to the
derivatives.
L minus 1.
Um.
Yeah, I'm doing the first derivative first. Sorry. And then you have R squared, second derivative term. That's L times L minus 1 times R to the L minus 2
Right.
equals lambda times R to the L. So it looks like all the R, the variables all cancels because of the Cauchy-Euler structure.
Yeah.
So this way we get lambda equals L squared plus L.
L squared plus.
And it simplifies to L times L plus 1. I think this is going to be helpful. Because it's in a ball, right? So the solution must be bounded at the center. So L cannot be negative. So yeah, so this is what we can say so far based on the radial equation.
Right.
As for the angular part,
it's getting kind of messy.
right now we have, okay, so right now, yeah, it's okay. It's perfectly fine. I mean, it's perfectly clear.
Yeah, at first, or
Okay,
we're
so
trying to like work backwards from
we
the
need to
Legendre
convert
form.
the angular part to a Legendre equation. So
I'm kind of rearranging things. Okay. So yeah, I was just doing this change of variables carefully was the part that I was.
Can we expand it? Expand, just once again, use the product rule.
Yeah. No reason we can't. The person who asked the question was saying that like it might be easier to keep it not expanded, but we can see what it looks like.
Theta.
I guess like sine theta.
Okay. So I'll try not to expand it. Sorry. Maybe...
I mean, it's not a big deal to me, but sine theta, big theta.
Okay, so far we have on the... You know what? What's the worst can happen? Okay, I'll try to expand. I mean, if this turns out to be useless, I apologize to the person who raised it and can't.
No, it's okay. We can do whatever looks more comfortable.
And okay, so you... sine of theta times h double prime. Okay, so I expanded the left-hand side. So that's cosine of theta times theta, big theta prime. And the right-hand side is minus lambda. Lambda is L times L plus 1 that we just got. Times big theta times sine of theta. Mm-hmm. Yeah. So we want to do a change of variable, right? So as we started earlier.
Right.
So theta right now, big theta right now is a function of little theta. We want to write x equals cosine of theta. This way,
Yeah, I'm just gonna get rid of that
d
work.
big theta over d little theta is d big theta over dx times dx over d little theta. That's a chain rule.
Right. And we
So,
know what dx
all
to
right.
theta is.
So dx over d little theta is just sine of theta.
Negative sine theta, but yeah.
So, sorry, yeah, negative sine theta. You're right. No, sorry about that. So this way we have the d big theta over d little theta equals d big theta over dx times minus sine of theta.
Oh, and then I guess we'd want a second derivative too if we're going to do the expanded version.
And then, yeah, and then we do it exactly. You need a product rule for the second derivative. I know this perhaps is not the most efficient, okay? It might not be the most elegant way, but I think this should work out.
Okay. I'm okay with not being perfectly
You just
efficient.
differentiate the product. Yeah. Right. So this way you get, you got to use the chain rule again on d theta over dx, remember?
Yeah, I kind of left that part alone because I was still trying to. I guess it's the same thing we just had.
Needs to be in terms of derivative with respect to x. Yes, so this will be d over dx acting on d big theta over dx.
Hopefully I'm not making
times dx
weird.
over d theta.
Okay, yeah.
And then times minus sine theta. And then plus d big theta over dx times the negative cosine theta.
Okay.
Yeah, my calculus is kind of rusty actually. Yeah, all right. So now we should have the second derivative of theta with respect to x.
Wait, my actually
So this d square
I'm getting
big
confused
theta
again.
over dx squared. Oh, sorry. Is there anything wrong?
Oh, just what to do with the second derivative of big theta in terms of x.
Your square bracket, that's a second derivative, right?
Right. And then that's minus sine theta
We're going
again.
to substitute everything. We're going to substitute.
Oh, okay, yeah. It's okay to okay. Yeah, I with this stuff I always just get confused with what symbols we do and don't want.
Yeah, so it looks like we're on the same page.
Okay. Cool. And then we'd apply it to this equation up here.
Okay, so now we have the two derivatives of big theta with respect to little theta. We can just substitute
Right.
to the left-hand side of the D and see what happens. I'm just gonna probably take some algebra.
Yeah.
So we got
What is sine theta in terms of x, though?
right. So okay, so let's do the left-hand side first. Sine of theta. No worries to don't worry about the x yet. Okay, don't worry about the x yet, because
Oh, I guess we're going to have other sine thetas to deal with in here that will make it
eventually we
cancels.
will see if there's squared. Yeah, we hope we'll see sine squared this way.
Cosine theta.
So your left hand side, yeah, this is what I was talking about.
Yeah, I guess we'll get a
Should
sine
we write in
theta
the same
divides
thing?
out entirely, at least. Big theta.
And then plus a cosine of theta times the first derivative.
Yeah, actually, I just realized I could screen share in Discord too, so there's less stream delay.
Okay,
Might
and the
make it-
right hand side, it's okay.
Oh, okay.
I can see what's on your screen. I can see I'm watching the stream right now,
Okay.
so we are on the same page. So does it look like we can perhaps cancel some stuff out? Looks like we can't cancel a
Yeah, sine. Oh, and then our first
the sine
derivatives are actually going
is
away.
canceled out. So this way you end up with d square big theta over dx square times sine square of theta.
Yeah. I think it reduces a
Minus
lot.
2 cosine of theta times d big theta over dx.
Oh, it doesn't cancel. Yeah, I was hoping the first derivative terms would cancel entirely, but
And
they
the right
don't.
hand side is minus L times L plus 1 quantity times big theta.
Oh, yeah, I forgot we can use our L's.
And now we're good, because cosine of theta is x, and sine squared is 1 minus x squared.
Aha, okay.
That's the Legendre equation.
Got there in the end.
Yeah, Hamiltonian dynamics, we're looking to solve inside the sphere.
Yeah, I'll show the question on screen quickly here.
And you can write the left-hand side as a product rule too.
Yeah, to get it back in the form that like they usually show Legendres in.
Yes.
Okay.
Like the more compact form.
It should just match that.
This looks like a d over dx acting on minus x squared times sorry, 1 minus x squared quantity times d big theta over dx quantity.
Right.
Yes, exactly what I was.
Okay. So okay, I'm just rearranging things for no
That should
reason
be
right now.
the Legendre equation.
Okay, cool.
You see, it might not be the most elegant way because I expanded everything.
Yeah, I think the other way, it probably was shorter, but I was struggling with it too, so seeing
but it
expanded
worked
was
out
easier
at
for me
the
too.
end.
Find the bounded eigenfunctions. I guess it's probably a thing we just take from Legender's, like, the Wikipedia page.
You just use a Legendre polynomial that's bounded. The second kind is unbounded. Chat says you can avoid expanding during d over dx as a chain rule. I see. I see.
That too, we're starting with the generic form and trying to make it match the problem, which is also making it feel a little weird.
Yeah, in the middle, here in the Wikipedia.
Oh shoot,
That's
with the way it's hard to say. Legender's. Okay, let me go to a different definition.
I think the question asked for us to prove orthogonality.
That was one of them. I think that was the later part.
That's part D.
Yeah. I don't know what these Legendre polynomials actually.
So what's the
look
condition
like.
here? It says on the boundary is cosine square of theta.
Yes.
Mm. The thing is, we still need to restrict L earlier, you know, the L from the radio part.
Right. Do they get restricted from the boundary condition?
It's like you need a quantization. You need the eigenvalues to be discrete.
That's what I would expect. I don't know how to actually get that.
Yeah. Me neither.
It's probably going to be the orthogonality piece, or I don't know, maybe not.
I think in the orthogonality relation, you already have n and m being integers.
To be finite at the center. Oh yeah.
It needs to be, yeah, so it needs to be finite at the center, therefore L has to be non-negative. Yeah, we got that part.
Okay.
The orthogonality is just there for fun. Yeah, that's right, because it's kind of not specific to the question. Yes, discrete eigenvalues should come from boundary conditions. Yes, that one's, you would expect that, right? You would expect that from, say, like a regular Fourier expansion.
The reason why it needs to be finite at the center, I think just because it's a physics problem, and we don't
But now you
want things to
have
blow up
a
in the middle.
cosine.
It's a physical
It's a physics
situation, I
argument.
guess. It's a PD's problem, but like a physical situation, yeah.
Mm-hmm.
So I understand the bounded eigenfunctions are Legendre polynomials, but like, it's not very satisfying to just say Legendre polynomials, because I don't quite know exactly how they look. I guess the first few are calculated, but like, or on this Wikipedia page that I've had open.
Yeah, it's something like well known, considered well known. The original derivation is like you expand the solution as a power series.
Oh. Yeah, I don't want to do that by hand then.
And then you get the few of them, and you can do all sorts of crazy stuff. You derive a recurrence relation. The special functions in mathematical physics is crazy. It's so many formulas.
Yeah. Have you seen that website DLMF? I think it's like Digital Library of Mathematical Functions. It just does like a bunch of things like that, and it's kind of it's crazy.
Yeah.
No, it's like all that like
yes, pretty
relevant.
much.
Yeah.
It used to be in a book called Abramich and Stegen.
Okay.
Do you know that book, Don?
I don't think I do.
Yeah, so that book has all the tables. I mean, it's like super old school. It's pretty much the book equivalent for the digital library nowadays.
Oh, okay.
I think the U.S. government compiled it during the Great Depression and the Second World War.
Really? I didn't know that.
Many of the quote unquote human calculators for women.
Oh, that's actually kind of cool. Like a piece of history.
Yeah, but back to the problem. I don't know how to reduce the eigenvalues to discrete values.
Yeah, I mean, I that's why I'm still like
Mathematics for physicists is easily the most dreaded physics course for physics major where I'm from. Yep.
oh funny.
Yeah.
I I want to go back to like our definition of view from the separation of variables.
Chat says
I just don't know what to like if we have Legendre polynomials as our solution for theta though, like I don't know what to do with that. Like how do we apply a boundary condition to that? That's what I'm like struggling with.
yeah, I'm thinking about the same thing. I think we should first say something about L. L needs to be quantized first before we move on with to the theta differential equation. The thing is, if L isn't quantized, if L is like a continuum, the Legendre differential equation has a solution that is an infinite series. We should have a polynomial. We should have a polynomial. That's the thing.
Okay.
Like if the eigenvalues are integer valued, the infinite series solution truncates, becomes a polynomial. But first we need to show that.
Breskels, who is the person who asked the question, says make it into a Fourier series and solve for coefficients. Don't think that much about the eigenvalues.
Like, can we say, okay, like going back to the radial equation, I think we can say something about it. But this feels like cheating though.
Okay.
John, like hear me out. I think L should be only integers because the harmonic functions should be infinitely smooth.
I think, I mean, I agree with the
If
outcome. Like,
let's say L is a fraction, then at some point, differentiation will give you something like a r to a fractional power, and that fails to be differentiable. So it's like if you differentiate the square root of r, you get a singularity at the origin, right?
right.
And that's not allowed. The harmonic function should be smooth at the center. So this way, L can only be integer. That would be my argument. But you're kind of invoking the smoothness of the solution. Why did it have to be infinitely time differentiable? Well, that's the thing, right? So I think, yeah, this is some outside help. This is from what we call the potential theory.
Yeah, that is just a property of harmonic functions. They do have to be infinitely differentiable.
Like if you consider a 2D situation, right, then the harmonic function is a component of a complex analytic function. And a complex analytic function is infinitely smooth, but that's 2D. Right? I think it should be 2. What does the solution have to be? But yeah, that's basically the reason. I think that's kind of cheating. It's not from the boundary condition, but it's from the solution property. So you see here from the Wikipedia page, this differential equation has a regular singular point at x equals plus or minus 1. I'm reading from the top.
Okay.
So if a solution is sought using the standard Frobenius or power series method, the series about the origin only converges, okay, for x half squared less than 1. You can show that when lambda is n times n plus 1. I mean, I'm not reading it, okay? I'm just saying, like, you should be able to show that when lambda is n times n plus 1, the power series solution is actually a polynomial.
Yeah, Wikipedia just kind of claims it. I don't think they explain why.
And that's the bounded solution. Because it falls, actually says it falls under the larger framework of Sturm-Liouville theory. So it did not explain it here.
I guess that's fair.
Like Sturm-Liouville theory deals with this sort of differential equation in general.
Right.
So that kind of solves, quote unquote, part D.
Yeah, I guess I wouldn't know what to write for the answer to part C.
You can just say by Sturm-Liouville. Boom.
Yeah, I mean, we're allowed to just say Sturm Liouville and wave our hands, I guess.
I think because of the boundary condition is very easy here. The boundary condition is cosine square of theta. It actually matches very closely, one of the Legendre polynomial.
Yeah, I think I was seeing something about that. Maybe.
So Legendre, can we see the first view?
Yeah.
You see the P2. P2 has to do with the x squared. So that's like a cosine square.
Right. Solution to C is Sturm-Liouville.
So if we have P2,
Hmm.
if we have, okay, first of all, what's the general expansion here? U r theta equals U r theta equals, all right, so when L equals 0, we have a constant, which I think is allowed. And then times P0 exists, right? P0 is a,
Yeah, P0 is just 1.
so you have a P0. P0 is just 1, right? P0. So that's just a constant. That's just a constant. Let's just call it C1. C1 plus C2. Actually, let's see C0. My bad. C0. And then plus C1. C1 should be just an R, because that's R to the 1 times P1 of cosine of theta. And then plus C2 R squared P2 cosine of theta, and so on. And so on.
But the Legendre
Don,
polynomials,
are you following me?
no, like, they came from the angular equation, not the radial equation. So why are we plugging R's into
Sure.
Legendre polynomials?
Yes, they do come from, going back to the separable solution. Yeah, so if you go back to the separable solution, it's a radial part times angular part, right?
Right.
The idea is the general solution should be a superposition
Yeah.
of the separable solutions. Like a linear combination, infinite series. So it would be, because we already quantized L, right? So the lowest order separable solution would be constant, because that's R to the 0 times P of 0 of cosine of theta.
It's P of 0.
That's a
Yeah, I'm
constant
sorry, I'm
term.
really not following
So you
this.
should have a constant term. And then the first order terms. First order term would be C1 times R to the 1 times P1 of cosine of theta. We're just listing the possibilities here and do a linear combination of them.
So
Think
are you
about
using
the
a power series for
possibilities
R
of
then?
separable solutions.
So
No. R has to be a power function, remember? R, we solved it. Here, big R is
oh, it's R
little
to
r
the
to the
L.
L.
Okay.
Here, you're
Right.
scrolling way
Yeah,
too.
I remember now.
Right here. Yeah, that's our, because of the Cauchy-Euler dE.
Okay.
And L is now quantized. L is 0, 1, 2, and so on.
So
Yeah, we justified it first based on the fact that the center, the solution should be bounded. And then based on infinite smoothness, L has to be an integer.
and then you're saying like
No. So this is not what I mean. This is not what I mean. So
okay.
when L is fixed, okay, when L is fixed, the corresponding solution of the Legendre equation is also fixed,
Right.
because the Legendre equation depends on the L. So
It
that's
does, yeah.
why when L is 1, big R is just R, and big theta is P1 of cosine of theta.
Right.
Okay.
So
Hamiltonian mechanics. I know there's probably other justification for L being quantized. I'm kind of cheating. Okay. Okay, is you say theta equals 0 if L is not an integer. Close up theta equals 0. Theta equals 0, that's like a radial direction. Okay, but anyway,
yeah,
regardless of the justification, let's just assume that L is non-negative integer. Okay, we'll come back to that. We're just trying to get to the answer of this problem. Right, so Don, what you had is the general separable solution, L to the R times PL of cosine of theta, not PL of theta.
oh, okay. Yeah, that makes sense.
Because we did the change of variable, x equals cosine of theta.
Right.
So let's just write down the first couple of terms. When L equals 0, we get just a constant, just 1.
Right.
So U is just, let's give the U a subscript. Let's call it UL.
Oh, yeah, sure. U1, U2.
Yeah, U. So U0 is 1.
Oh, thank you.
U0 is 1. Is it, Don, you messed up the subscript. Yeah, no
Yeah.
worries.
I have 3x squared minus
U2
1.
is R squared times, yeah, just use the formula from Wikipedia, P2 for P2.
Okay. And so on like that.
Change x to
Oh,
cosine of
thank you.
theta. Change x to cosine of theta.
Okay.
No worries. I think that's all we need. That's all we need because of the boundary condition. It's just a cosine square. So because of linearity, the general solution is a superposition of all of these UL. So it's C0 plus C0 U0 plus C1 U1 plus C2 U2 and so on. You can write it as a sigma notation. It doesn't matter.
Okay. That helps me see what like how this actually works. That's not right. CN UN. Okay.
CN, yes, UN. Yes, pretty much. Pretty much. So because of the, and we evaluate this at R equals 1.
To check the, okay.
So all the R power is just 1. Because now we can use a boundary condition.
Right.
You should only end up with a cosine square. So this puts a constraint on the coefficients.
We only end up with a cosine. Oh, sure.
And I don't think we need the Legendre polynomial with degree higher than 2.
Yeah, we're going to set all those coefficients to be 0, I guess. You have 1, 0 equals.
But to be, yeah, to match the boundary condition, not all of them should be 0 because it should be cosine square of theta.
Yeah. So that implies even C, well, okay, maybe C0 we probably have an
Should
actual
be C0. Yeah. Should be, if we write down, okay, so should be C0 plus C1 times cosine of theta.
C1 cosine, yes.
Plus, actually, is P1 X though? I'm not sure. Because I'm super rusty with Lugano
It
stuff.
is. Yeah.
Okay, it is great. Okay, and then C2 times 1/2 3 cosine square of theta minus 1. And that's it. We don't need anything of high order.
Yeah. Everything's works more
Because
room.
this would generate, because otherwise you would have higher powers of cosine that you don't want.
Oh my god, I just did something terrible.
So this way you get a system of equation for the coefficients.
Yeah, I can see where this is going now. We're gonna be able to actually see what these coefficients are.
The constant term is C0 minus half C2, which is a 0.
C2. 3/2 C2, right?
And linear term should be 0 too. So C1 is a 0.
Yeah. Oh wait, I see what you're saying with
And finally, the second order term should have a coefficient of 1. So this way you get
3/2 C2 equals 1.
3/2 C2 equals 1.
Okay. Yeah, I think this is correct.
C2 is 2/3. C1 is 0.
Minus.
And C0 is half C2, which is a 1/3. And
Okay,
we're
cool.
done.
There we go.
So UR theta finally is 1/3 plus 2/3 times R squared P2 of cosine of theta.
Half 3
And
cosine
substitute
squared
P2
-1.
for final simplification.
Okay. God, that took a lot more thought, or a lot more like thinking than I thought it would.
Actually,
yeah.
Actually, never mind. I think the solution itself is a polynomial.
And R and cosine theta, I guess so.
R times cosine theta is isn't that an angular?
X.
Is that a coordinate? R cosine
yeah,
theta?
X equals R cosine theta.
Is Z, right?
It should be X.
That's Z. That should be Z, no?
Oh,
think about the
I don't know.
we have the axial symmetry, so theta is, that's why I was asking at the beginning. Theta is the
It is in the XY plane.
theta is the inclination angle. You have theta is in XY plane.
Theta is in the XY plane in this
confused
problem.
Here. It says you have axial symmetry. Which is a little bit ambiguous. Sorry, it's a little bit ambiguous. But anyway, we can have the solution.
Yeah, and it's been confirmed that we got it correct.
Our cosine theta here should be Z. You see, that's the thing. Don, the angle that you just drew on the XY plane, I think that should be the other angle.
I think we were saying that
this is odd.
This is the convention that I was always taught, at least in math classes, and Brett schools said this is the convention for this problem.
So the thing is, the spherical coordinate in physics and in math use different conventions.
Yes. But I asked this when we were first talking about the problem, and it was confirmed that it's the math convention for this problem.
The Wikipedia uses the physics convention. Did you
It does?
borrow the formula
I
from
thought
Wikipedia?
Oh no. They didn't say, and I just hope that they use the same convention that math does.
Don't. I think we still got things correct. It's just a matter of interpretation now.
Okay. Yeah, Wikipedia wasn't specific about.
So I'm looking at the Wikipedia page for spherical coordinate system.
Oh, it does say down here.
Yeah, I'm looking at the Wikipedia page for spherical coordinate system, and so let me see if there's a formula for Laplacian in that article.
That's a better idea, because the Laplace article.
There is. Yeah, there is. I just searched Laplacian, and it pops up.
Yeah, I guess I did get mixed up then.
Compared to the one we just used.
It is.
Let's do the screenshot over that
yeah, sure.
formula and compare with the one we have.
Same formula.
Yeah. It's the same. It's the same. So you're right. You're absolutely right. You're absolutely right. So I was wrong.
Are you sure? I think I was wrong, because the diagram has theta and phi as you say.
About theta being. No, really? I think I'm confused here. You drew it right.
Wait,
you drew it right? No. Oh, sorry. Theta. Oh, wait.
Oh,
theta
I was misinterpreting what axial symmetry maybe means.
Theta is the.
Yeah, if we're actually okay, I actually was right for the wrong reason. I think.
Kind of vague. Which axis, right?
Well, I think they mean the z-axis. That's usually
okay. So now we have the theta correctly interpreted.
Yeah, I was picturing the wrong thing the entire time,
yeah.
But I did happen to do the right thing.
Usually. That's lucky.
Yeah, better lucky than good.
Okay. So yeah, I was just saying that the solution itself seems to be a polynomial, because r cosine theta is z. So the solution in terms of Cartesian coordinate would be
well, what about
1/3 plus z squared. And r squared is just x squared plus y squared plus z squared.
Right.
So that's actually a polynomial. It's kind of nice.
Yeah, that is interesting. Oh shoot, don't do it on that one. Z squared minus a third squared.
And as we can clearly see, on the surface of the sphere, you have x squared plus y squared plus z squared being 1. So you just have a z squared.
Oh yeah, sure.
You just end up having a z squared, which is cosine square of theta. And that's exactly the boundary condition. That's a nice check.
Yeah. Well, that is weird how it's just a polynomial. All that work.
Okay, so I think still there's a controversy in our deduction, like how did L become an integer, right? So I think chat was
Um,
telling me that it's because of has something to do with theta equals 0. Chat was telling me that.
yeah, I think Hamiltonian dynamics was saying that. From the angular equation, apparently.
Yeah.
Um, I don't know how to just like.
The way I argued it
Hmm.
is because of infinite smoothness, which I think should work, but perhaps a little bit of a overkill.
Yeah, they cite Sturm Liouville. I
Any
wonder.
reason here, given in Wikipedia, why should L be an integer? Because that argument is a little bit odd. You usually get quantized eigenvalues from the boundary conditions. I agree. Just like in the regular Fourier expansion.
Um, the other ones blow up at x equals
Let me
cosine theta
see
equals
how.
1.
Okay. Antonio says the other one blows up at x equals 1. Hang on. If L is a non-integer, say 1/2, how come it blows up? You mean x equals 1, that's on the surface, right?
Yeah.
If L is 1/2, that's the square root of r, it doesn't blow up. But you have a singularity at the origin. The square root of r has a singularity at the origin. And the same problem exists for all the fractional powers.
Um,
And cosine of theta, x is cosine of theta. And when theta equals 0, you get x equals 1.
yeah, and Territory in the YouTube chat said this earlier. It's
Yeah.
like when you have.
For this problem, x equals 1 means it's just a point on the sphere, right? Because r equals 1.
Yeah. I think I might be something to do with like cosine of 0 needs to equal cosine of 2 pi.
But I don't see how that would lead to L being an integer, though.
Because only an integer multiple of pi would have that be true? Well,
Lucky me, I have a 930-page textbook on SL theory. My goodness.
hmm.
Not X. Okay. Yeah, we'll think about it. We'll think about it for sure. Because it does, Hamiltonian, it does strike me as a very weird argument from the point of view of smoothness.
Only finite at cosine theta
Typically,
equals
you
1.
would just get quantized eigenvalues from the boundary conditions. Yeah. Those solutions are only finite at cosine theta equals 1 for integer L. Cosine of theta equals 1. Cosine of theta equals 1. That means theta is, you mean at the North Pole, right? Cosine, remember what theta means in the spherical coordinate. That's the North Pole.
Um,
of the sphere. Theta equals 0. Does theta equals 0? Or,
Equals 0.
sorry, yeah.
Or, oh yeah, okay, sure. And it's, I guess we have cosine squared for
That's
the boundary
just the
condition,
North
so it means we're
Pole.
out pi also, like the South Pole. I guess that's for the boundary condition though. I don't know. Also let theta equals pi.
Yes, I agree with Taratar on YouTube chat. Discrete eigenvalues should come from boundary conditions. That's just like the regular Fourier expansion. But here we have, what's our boundary condition? It's not like a regular Dirichlet boundary condition, you know?
Right.
Or a Neumann boundary condition. Thing is, like for the Sturm-Liouville problem, the boundary conditions are the can we say boundary conditions being homogeneous, that is something equals 0, that's like function equals 0 or the derivative equals 0. But here we have on the surface u equals cosine square of theta. I don't know what to make use of that. Yes, I mean Taratar, I totally agree with you. That's like the standard Fourier expansion on the interval. But here we have boundary conditions on the sphere, which is cosine square of theta. How do we make use of that and say L is integer? We actually used, we actually assumed that L is integer so that the series solution matches the cosine square of theta. That's how we got our solution.
Yeah, that I don't know. I feel like we have the pieces here, but there's something. It's like a little subtle. That's just a little weird.
Can we AI and see? I don't know.
I'm not above it. We can ask
I know it's dirty.
ChatGPT. What? How do we phrase this question though?
If we demand the solution to be regular at x equals plus or minus 1, I say
Legendre's differential equation integers.
hi Leo, we're doing PDE, Laplace equation in spherical coordinates.
Yeah. And look away, Leo, from what I'm doing on the screen right now.
Nah, you're a big Leo. They aren't automatically integers.
I should have included the boundary condition when I asked ChatGPT this, but
Okay, yeah. So this is very similar to what Hamiltonian was saying. For which values of lambda does there exist that is well behaved at both endpoints? X. Okay. So
occurrence terminates.
yeah. So I think So the I think Wikipedia was saying. I remember. Yeah, I remember Wikipedia was saying like the power series has a radius of convergence of 1.
Mm-hmm.
It has a radius of convergence of 1. So and that's what happens in general. Okay, that's what happens in in general. Of course, if you have a polynomial, it is well behaved everywhere. But the thing is, you want the solution to be well behaved at x equals plus or minus 1. That's the reason. I think that's the reason. That's a boundary condition explanation. For a generic lambda, the recurrence doesn't terminate. Yeah, seems to be a good explanation. Yeah, yeah.
HUD has a whole like widget thing in here. I don't know if it's actually relevant, but I didn't know that it could do this interactive stuff.
The special values lambda equals n times n plus 1 are exactly the ones for which the solution can remain regular. I see. Yeah, sorry, Hamiltonian. You've been trying to explain that forever. I know. Like, sorry about that. I just never. I forgot about the radius of convergence. I forgot about the radius because when x equals plus or minus 1, the second derivative in the Legendre ODE is 0, which means you have a singularity there.
I'm just
So
sending
we
you the
want the
ChatGPT
solution
response
to
if you
be
want it
well
for yourself too.
behaved when x equals plus or minus 1.
Hey, Lucas.
One subtlety. You will say,
Oh, sorry if I just scrolled away.
so the integers aren't arbitrary, the consequence of quantization condition. Don't say you would rather blow up the earth than read it.
It's just too much category theory
I
for
give it
me.
a first glance, actually. I haven't read the details yet. I really want to understand more about the Menshov set that you mentioned in that post about like I find like the animation is pretty cool though. I'm actually Dawn. Your voice is kind of weak right now.
Rest saying page
See that
100.
Stanford link. I don't know what that is.
I can send it to you.
No, don't hate the
DM.
animation. Like drinking poison bees.
How do you drink a bead?
Oh, wait, doesn't like counterexamples in analysis?
No, I do like them. Leo just likes to make fun of me because I don't consume his content enough apparently. And so I did read pieces of his
What?
blog post, but
I
I kind
mean,
of
I
skipped
don't
over the
know
category
about
theory stuff. Sorry, what?
Okay, what's the explanation here? It says m must be an integer. Is that m? What's m? Is this quantum mechanics?
I think this is a quantum mechanics. As soon as I
Looks like
see
quantum mechanics.
size, I assume it's quantum, but it's probably still relevant. Like,
Yeah, this is quantum mechanics. This is
page 55
Yes,
of
the
the
quantum side.
oh wait, that's a
That
different one.
doesn't matter. I think
Yeah, it's the same equation.
I saw Legendre somewhere. Do you see? Yeah, you see
Control
the
F.
Legendre?
Oops. Legendre.
Why do we have two indices though, m and l?
Dang it. I'm messing this up.
Legendre functions, spherical harmonic boundary conditions, hydrogen atoms.
They're all on the next page. Okay. Get good nerd quantum moon. Okay, see you, Leo. If our series solution doesn't determinate, just terminate. We'll get singular solutions diverging at x equals 1 or minus 1. Equations right after the first paragraph.
Yeah, yeah, yeah.
Uh,
Yeah, that's Hamiltonian's point.
okay.
I like this explanation better because it reasons purely on the basis of the Legendre D itself. My own argument would involve the radial equation.
I think I'm still getting the wrong part of this PDF.
Like, you see, my argument earlier was that the radial solution is R to the L. To be infinitely smooth, L must be an integer. Which is not the Legendre equation. So Hamiltonian was totally onto something.
Okay. Yeah, my brain is starting to get cooked from doing this for too long. That's part of why I'm having a hard time like following now. I don't know. I might want to call it here for this question because someone else asked a question earlier. I'm not sure if they're still here, but I would like to work on that one. But yeah, Ming, thank you for coming on and for helping me out with this problem. I need to find what the person was asking me. Stay tuned for part 2. Mm-hmm. Hey, Sesh, are you still here? Okay. And anything else about this problem, Ming, before I move on? I can't hear you now if you are talking. Something happened to his internet or something? Or his microphone? How high is up? Very high. Okay, he left the call. Okay. I assume he was having a tech issue at the end there. We Okay. Sorry that I wasn't able to like respond to chat as much as I usually would. Whenever I'm in a call with someone, I feel like I'm being rude if I'm talking to chat more than I'm talking to them. You are here, Sesh. Okay. The music, did I pause it on purpose? Oh no, the music stopped on its own. Just quickly play a song. You're not going to see into the question? Yeah, but Rescos, I'd like to understand this for myself. I want to understand Sturm Liouville in general. It seems really important. Get the solution from divine inspiration in a dream, then use uniqueness of solutions. I should have. That's basically differential equations for you. Show that Legendre polynomial is conform with Fourier series solutions. Yeah, it is kind of crazy that we got a series solution like that. Okay, another rotated picture. Is this 1 times x to the 1? I guess it must be. From 0 to 4, you get a half x squared from 0 to 4. Times 4 squared. I have a hard time reading your writing there. You do get the final answer is 8, and that's right. So yeah, I would say you follow the steps correctly of doing this integral. And yeah, like Venlock says, you could just like figure out the area of the triangle too with a half base times height, but integration is more fun. You did this correctly, I'd say. Turning my head 90 degrees to the right. Looking for the orthogonality part of the question. Oh yeah, I didn't do that. It is kind of weird when you can find polynomials that are orthogonal like this. I guess you'd have to use like one of the recursion, or I don't know. I I felt kind of bad because I stopped being able to follow this at some point because I'm just getting so tired. Nice job, Sesh. Yeah, you did just integrate a function and you did it correctly. So nicely done. I don't know. I want to learn this, but the more I look at it, the more my brain hurts. I don't know. Is there a different question that anyone wants to ask me about? If not, I'm trying to think of something that's like on the easier side that I can do. Solve a Rubik's. Oh hey, I can do that. Where's my timer? All right, let's scramble it. 2 numbers from 0 to 10, 3 and 7. This is just me scrambling it. Okay. Inspection time. Oh my god, my eyes kind of hurt right now. I think I've been looking at screens for too long. Like it, I can feel my eyes watering now that I'm looking away from a screen. Not a very good solve. Thank you though, Femux. Honestly, Femux, it's easier to just learn how to solve a cube. Too many orthogonal polynomials. There are a lot of them floating around here. I'm gonna keep. I have too many windows open. Sorry, I feel like I should shout him out again. That was a Math with Ming on YouTube. Who I was talking about that problem with. We're actually like, it's kind of funny how similar our interests are. We're both applied math people. Legendre Anonymous. Yeah, I'm addicted to Legendre polynomials. It was really funny to realize that I was wrong about the coordinates, but I happened to be correct about the problem. Like you said, Hamiltonian dynamics just make an even number of errors. Sturm Liouville-aholic. Oh. Uh, I should have known this. Laplace's equation holds for gravity too, though. Like, you can do it for gravitational potential, not just electric potential. Newtonian gravity, yeah, yeah. Feel free to link it, Breasticles. Your name sounds even funnier when I stutter on it. I don't know if I'll understand it, because I'm in a like tired state right now, but we should at least try. Skimmed it, but it seems correct? Okay. Yeah, I mean, it's funny how simple it is, but it's still so applicable. I got really excited in my PDEs class when we were learning about Laplace's equation and like the stochastic interpretation or the probabilistic interpretation, whatever you want to call it. And I realized that it was pretty freaking similar to something I did in an E&M class with electric potential, where you can numerically find electric potentials between like conductors just by taking like the averages. You fall through the center of the earth, you do simple harmonic motion. Really? Because I've heard of that problem before. Like if one of my physics professors talked about that problem. I forget what why it came up though. First exam for Brownian motion. Oh, that I don't know about. Oh, okay. We have some actual images for the textbook excerpt. Can't ensure it's well ordered. The set is not well ordered. Electric circuits are equivalent to Markov chains. That's the discrete version. I did not know that. I could sort of guess maybe how that would work. I need to think about it more though. Oh, did I choose bounds for your integral? Hey, and it's not rotated this time. Oh, you found you get a negative answer because you reversed the bounds. Normally you put the lower number on the bottom, the higher number on top. You're not wrong to do it like this, but that's why you get a negative answer. So yeah, for this problem, as you wrote it, this is correct. I should say, well, I didn't check your actual work. Maybe I should have done that. 9/2 minus 49/2. Wait, I don't know what the extra 2 there is. Wait, this can't be correct. Wait, maybe it can be. 9/2 minus 49/2. 58/2. No, sorry. Yeah, minus 20. Thank you. It's a question mark. Oh, I see. Yes, minus 20 is correct after struggling with basic arithmetic. Yeah, and so that's the correct answer for the problem that you wrote here. And it's okay, like integration, it's possible to get negative areas in integration. It like the reason you get a negative thing here is a little bit weird to explain, but if you swap the 3 with the 7, that's the more natural thing. You would just put the 7 in front and the 3 here. Like in this line here, just swap the order of the 3 and the 7. That's the only effect it would have, and you'll get positive 20 instead. Okay, back to the partially well-ordered Kamar equation. Sorry. Awesome, Sesh. That's great to hear. I don't know what book this is. Vesicles, can you say where it came from, by any chance? The Sturm-Liouville phone book? Oh yeah, the Sturm-Liouville phone book. Looks great. For the low price of $135. I guess that is hardcover, but still. Ooh, derivative of the gamma function? Look at that. You don't see that every day. I haven't found the relevant part yet that I can see. M sub leg? Digamma function? I don't know how any of this is related. Maybe I just missed it though, and I'm just stupid. Oh, it's in reverse order? Okay. This is supposed to be related to the stuff that we were just talking about, Ming, for why it's integers. Here's Legendre. I think this is gonna be too complicated for me. Yeah, I saw the ChatGPT tab open. I want to read it maybe off stream. This book is maybe too much for me. Definitely too much for me right now, at least. Whenever I'm already 4 hours deep into doing math. This is going to be well behaved x equals plus minus 1, the singularities of the ODE. Yeah. And I just like believe that part. But I want to look back at the actual equations that they got and see it for myself. Theory solution becomes a polynomial. Okay. Whew. Fair enough. I think I should call it though, because I'm just tired. Yeah, it's been a fun day though. I think this will be the end of the stream. So yeah, the YouTube stream I'll cut off here on Twitch. Will look for a raid. So Ming and who's here on YouTube, thank you for being here. Also Ming, just shout out in general. You're a legend. Thank you for volunteering to suffer with me through that. Yeah. Hope you have a good day, Ming. Bye.